All right, let's get right into this explainer. Think about the massive machines that build, well, everything around us. We're talking equipment the size of a house. But before you can even think about bolting one of those behemoths together, you've got to look down at ground zero. You know, it's so easy to walk into a plant and just stare up at the towering steel and complex piping. But the real unsung hero, it's buried beneath your feet. Imagine trying to park 50 cars stacked on top of each other right on your front lawn. Yeah, it's just going to sink straight into the mud, right? To stop a 50-ton piece of machinery from shifting, sinking, or literally shaking itself apart, you need a highly engineered foundation. So let's break down exactly how civil construction teams actually pull this off. Okay, here's our game plan. We're going to look at the chronological 6-step recipe used to build a flawless equipment foundation. From the blueprints and excavation, straight through to rebar, formwork, precision templates, the big concrete pour, and finally, the curing process. Let's run through it. Now, the absolute key here is that this sequence has to be followed flawlessly, layer by layer. If you rush even one of these steps or mess up the math, you could compromise a multi-million-dollar installation. In this world, precision isn't just a nice to have, it is literally the only option. Step 1 on the list, the blueprint and excavation. Think about it like setting the groundwork for building a massive new global fast food franchise. You don't just start throwing up walls on the grass. You've got to dig into the earth to create a precise cavity based on the engineering blueprints. In heavy industry, this excavation step carves out the exact footprint where our load-bearing foundation is eventually going to sit. Moving on to step 2, rebar, which acts as the inner skeleton. So before a single drop of concrete hits the dirt, construction teams spend a ton of time cutting, bending, and wiring together a really complex grid of steel reinforcing bars right inside that excavated pit. You can basically think of this rebar as the heavy-duty skeleton of our foundation. And the physics behind why we do this is actually super fascinating. See, concrete on its own is incredible at handling compressive strength. It can easily hold up the crushing downward weight of a giant machine. But it's actually incredibly brittle if you try to pull or bend it. And that is exactly where the steel rebar comes in. Steel has amazing tensile strength, meaning it stretches and resists those side-to-side pulling forces. When you combine them, you get a composite foundation that absolutely will not snap under the crazy dynamic vibrations of a machine running at full speed. All right, step 3, anchor boxes and formwork. So we have to contain the concrete, right? That wooden formwork is literally just like a baking tin for a giant cake. It holds the liquid concrete perfectly in shape until it sets up. But notice the empty square pockets in the finished base? Those voids are created by anchor boxes placed inside the formwork beforehand. They intentionally leave these empty pockets because later on, the machine's massive anchor bolts need a secure place to be tied in. Next up is step 4, templates for millimeter precision. Okay, take a look at the steel frame suspending those bolts in the air. That is a template in action. For some vertical equipment, the bolts actually have to be set directly into the wet concrete. And you cannot just guess where they go. The template perfectly mirrors the exact bolt pattern of the equipment that's going to arrive weeks later. It holds those crucial anchor bolts completely still, so when the concrete is poured, they lock into the exact millimeter-precise mathematical alignment that's required. There are no do-overs here. But here's the catch. Once the concrete sets around the bottom of those bolts, the template itself is totally useless. It basically becomes instant scrap metal. And on an active construction site, you absolutely cannot leave jagged metal lying around. It's a huge tripping hazard and takes up incredibly valuable space. So strict safety protocols dictate that this scrap is immediately dismantled and sent straight to recycling to clear the deck for the real machinery. Which brings us to step 5, pouring the concrete. Because industrial foundations are so massive, standard pouring just isn't going to cut it. We are way beyond mixing a few bags in a wheelbarrow. We have to bring in the heavy hitters. Concrete mixer trucks haul in vast quantities of the mix, and then a specialized pump truck takes over. This rig has a huge, articulating arm that can reach way out over the site, dropping the heavy liquid concrete exactly where it needs to go without bumping into our delicate rebar or those precision templates. And as that liquid concrete completely swallows up the steel skeleton, filling every single corner of our formwork baking tin, the crew actually uses mechanical vibrators right in the mix. This is a crucial extra step. Vibrating the concrete forces out any dangerous trapped air bubbles that could create weak spots later, ensuring our liquid rock settles safely and uniformly into its permanent shape.
Finally, step 6, curing and the final reveal.
Now, a lot of people think concrete just dries out over time, kind of like a wet towel. But actually, it goes through a really intense chemical reaction called hydration. The water reacts with the cement to form interlocking crystals. It even generates its own heat, an exothermic reaction that can make it quite hot to the touch. This chemical transformation is what gives it that unbelievable rock-hard strength. In fact, engineers often let it cure for a full 28 days to hit its maximum structural strength. If it loses moisture too quickly, those crystals don't form right, which is exactly why the curing phase is monitored so carefully.
Once it is fully cured, the wooden formwork is stripped away. They backfill the dirt to make everything level, and boom, we're left with this magnificent, load-bearing concrete pedestal. You can literally see the perfect geometric shape left behind by the mold. What started as just a hole in the dirt has officially become ground zero for heavy manufacturing. So we've totally mastered the ground beneath our feet, but how in the world do you perfectly align a 50-ton piece of equipment down to the literal millimeter while it's dangling midair from a crane? Well, that incredible logistical ballet is a completely different puzzle, but definitely something to think about next time you walk past a massive factory. Thanks for hanging out with me for this explainer on industrial foundations, and I'll catch you on the next one.